Okay, so this is problem 2, part A from the first test. You have a dipole here with an electron on the axis. Questions asking you to determine the magnitude and the direction of the force on the point charge due to the permanent dipole. So for starters, just to show the electric field of the dipole, you'd have it going this way, due to the positive charge, and this way, due to the negative charge. So the equation for F is F equals the q of the particle times the electric field of the dipole. Written even more extended, you would do q of the particle times the magnitude, the electric field of the dipole, times the vector of the dipole. We're going to say that the q of the particle, since it's electron, equals negative q. So, magnitude of the electric field of the dipole, since it's on axis, would be 1 over 4 pi epsilon naught 2 q of the dipole times s, which is the separation, over r cubed. You're going to say q of the dipole equals q. So the electric field of the dipole at the point charge goes in the negative x direction, which can also be written as that. Right? So now we need our r vector. Our vector equals the observation location minus the source. Our observation location is at 0, 0, 0, which is where our particle is at, minus our source, which is at negative d, 0, 0. So the r vector will equal d, 0, 0. To get the magnitude of r, you just take the square root of all the points squared. So d squared plus 0 squared plus 0 squared, which just equals d. Then you just plug it all to the electric field equation. Saying that r equals d because that's the distance. It's this distance right here. So that'll come out to being 4 pi epsilon naught 2 qs over d cubed. And this q is the q of the dipole. Plugging you back into your force equation, you would get negative q, which is the q of the particle, times negative 1 over 4 pi epsilon naught 2 qs over d cubed, which is what you got for your electric field, times x hat. So your final answer for the force would be 1 over 4 pi epsilon naught 2 q squared s over d cubed. You get q squared because that q times that q, x hat. And that tells you what direction it's in. So you do part A of problem 1.